So today we talked about greatest common factors of polynomials. There are a lot of things that are similar between regular numbers and greatest common factors and the greatest common factors of polynomials. The first thing that we need to know is what a factor is. Basically all a factor is are two numbers that multiply together to get a bigger number. And I gave the example of today, 2 and 4 equaling 8, so 2 and 4 are my factors of 8. And we started off by looking at some numbers. One of the examples that we looked at was 63, so I'll use 63. And we did the prime factorization. Now, prime means that it can only be multiplied by itself and 1. And those are the only factors that it has. So we want to find the prime factorization. Which means that we need to find the factors of 63. And in 63, the factors we have are 7 and 9. Well, 7 can only be multiplied by itself and 1, so we're just going to go ahead and circle it because we can't do anything with it, so we're done with it. 9, on the other hand, can be factored by 3 and 3, as well as 9 and 1. But 3 and 3 can no longer be factored, so we're going to circle those. So our prime factorization for that was 3, and since I have 2 of them circled, I want to say 3 squared times 7, because that's my prime factorization, meaning if I do 3 times 3, I get 9, and I can multiply that times 7 and get 63. So I can self-check myself that way. Now, what the main part of the lesson today was factoring and finding the greatest common factor. And we used 54 and 45 as another one. So find the GCF, or greatest common factor. So I need to do the same thing. I'm going to take 54 and I'm going to do the prime factorization for it. So 9 and 6, which turns into 3 and 3, and 2 and 3. Okay? And then I'm going to take 45 and do the same thing. And I do 5 and 9. 5 is a prime number, so I circle it, but 9 is not. So I continue to factor and I get 3 and 3. Now I need to look at 54 and I need to look at 45. And if I put 2 times 3 times 3 times 3, 1, 2, 3, I can get to 54. Over here, I would multiply 3 times 3 times 5. So the factors that they share are 2 sets of 3s, which means that they are common between both of them. So my common factor would be 3 squared or 9. So that's how I find a GCF with just numbers. We're going to take that one step further. And the last thing that I'm going to show you for this is how to find the GCF using polynomials. We're going to look at 2 different monomials and we're going to try and find a GCF for both of those. We're going to look at 30y cubed and 20y squared. If I look separately at 30 and 20, I'm going to take the factors, and 30 would be 6 and 5, we could say. 5 is a prime number, 6 is not, so I continue to factor and get 2 and 3. 20, I could use 4 and 5, 5 as a prime factor again. And so I continue to factor here until I get down to 2 and 2. So the numbers that are in common are 2 and 5. So I can say 2 times 5 equals 10. So I know that the numbers part of this monomial is going to be 10. Now 10 to the what? I'm not sure. Since I know that I have y to the third, if I expand that, it would be y times y times y. If I have 20y squared, I would only use y times y. So both monomials have two y's being multiplied together. So that means that at the end, they share the factor of y squared. And my GCF between 30y cubed and 20y squared is 10y squared.